Hello everybody, it's Paige from the Helen Schuler Nature Center. Welcome back to the Home Eco Challenge. Welcome to my natural habitat here in front of a whiteboard. Today, we're talking about something very, very important, climate change. All right, so strap in because it's about to get deep, folks. Stick around. It's the Natural Leaders Project Home Eco Challenge. All right, people, so climate change is one of the most important phenomena for us to understand. So I wanted to make sure to cover it in the Home Eco Challenge. I thought I'd go back to the basics, so I headed into the Nature Center to use the whiteboard. Follow along as I draw out my own explanation of what climate change is. Let's start by drawing a picture of Earth in our solar system. Woohoo! We live on the blue planet, which is covered in water, and we have these large continental landforms. There's Africa, Asia, Europe, South America, North America, Australia, and Antarctica. And you can tell from my blurbs that I'm kind of approximating their shape. Basically, also Antarctica, I had to erase that one because it was just looking funny. I put Australia too low. None of this is important. Moving on. Our planet has always been changing. The sea levels rise and fall, the continents move all over the place, and the atmosphere also changes. The atmosphere, of course, is the bubble of gases that surrounds our planet and creates, well, the air we breathe. This atmosphere acts like a shield that actually contains the gases that we need and also helps to filter out some of that harsh sunlight that would otherwise be totally up in our grill. This is really important to understand, folks, because without our atmosphere, life here would not be possible. Not only do we need these gases to, well, breathe, and we need the, water vapor in the form of clouds to help transport water, but we also need this protective shield to keep our temperature relatively consistent. So without the atmosphere, our days here on this planet would be insanely, intolerably scorching hot, and our nights would be super duper freezing cold. So the atmospheric gases keep our temperatures relatively consistent. So there are many, many different gases in our atmosphere. Predominantly, it's nitrogen. It's actually like 78% nitrogen, but there's also about 21% oxygen. So those make up the vast majority of the gases in our atmosphere. Then you have a bunch of smaller amounts of gases, things like argon or carbon dioxide or water vapor, neon, helium, ozone, many of those other kinds of gases. Now, some of these gases are greenhouse gases, which are amazing. Shout out to greenhouse gases. Greenhouse gases trap heat in our atmosphere, and that's what makes, day and night not such an extreme swing of temperature. So without these greenhouse gases like carbon dioxide and methane and ozone, we would be hooped. But, and this is a big but, folks, much like Halloween candy, too much of a good thing is actually kind of terrible. In the last 200 years alone, the level of greenhouse gases in our atmosphere has skyrocketed, meaning that more heat, too much heat, one might say, is being trapped in the atmosphere. Now, we call this the greenhouse effect, and the greenhouse effect makes our planet warmer, which in turn causes polar ice caps and glaciers to melt. And this, in turn, causes our sea levels to rise, which I'm sure you've heard of. The thing is, we need to understand that this is bad news bears for anybody living on the coast, which is approximately 40% of the people in this world. It's a big deal. So where is all of this extra greenhouse gas coming from anyway? Well, there are several sources, things like deforestation and, of course, the agricultural industry, specifically the meat industry. But really what we're going to focus on right now are fossil fuels because they are a huge contributor to greenhouse gas emissions. Fossil fuels. We have to talk about fossil fuels for a second because we can't talk about climate change if we don't talk about these amazing resources. Now, first things first, fossil fuels are this extraordinary treasure from the past. They're essentially the old, decayed, ancient organisms from hundreds of millions of years ago that are squanched and crunched over time into these incredible resources. Fossil fuels, old, decomposed dino babies. Well, not quite, because you see, coal is actually made out of the decaying remains of old plant matter. For example, a tropical forest living and thriving here in this place hundreds of millions of years ago, those massive, massive plants would actually, well, die, as all things do, and they would fall to the ground and they'd create these layers of understory in that forest. And over time, as those layers built up and built up and built up, they would compress over time to form these chunks of coal. That's why when you look at coal, you can see almost like little layers. The coal is made up of like little layers. So actually, if you were probably to take, say, your living room at home, if you filled your living room so full of plants that like you could not even close the door, that amount of plant matter would make about this much coal. So it's really, really compressed plant matter. All right, super quick bonus challenge. If you're feeling up for it, if you're feeling adventurous, I want you to head out into the coulees and see if you can actually find a coal seam. A coal seam is usually along the coulees, and it's like an exposed area of land where you can actually see coal buried deep from hundreds of millions of years ago. So that's my challenge for you. Now, oil is a liquid form of fossil fuel, so it's also old decomposing dino babies, except that it's kind of not, because oil is actually made from like the decayed remains of old marine life. So coral reef and the bacteria that actually decomposed those things. That's why it comes out in a liquid through very many scientific fancy processes. But essentially oil is the remaining kind of organic matter from when this place was an inland sea. Yes, actually. Like this place right here, the dry, the scorching hot prairies, was once like an amazing coral reef, lovely inland sea. Lastly, we have natural gas. Now, natural gas was created by the decomposition of basically all kinds of different animals from hundreds of millions of years ago, both plant and marine life. The point is that when things break down, when things decompose deep underground without any oxygen around, actually the bacteria that are breaking those things down produce natural gas and other greenhouse gases. The point is, all of this to say, fossil fuels are an amazing treasure from the past. These things, hundreds of millions of years ago, had to die under very specific and unique circumstances. And we uncover this amazing resource, and what do we do with it? Well, what do you do with things that are precious and sacred and important? You kill them with fire! So when we burn fossil fuels, or when we combust fossil fuels, we actually release a huge amount of greenhouse gases, things like carbon dioxide specifically. Why is that a problem? Well, I'm glad you asked. So one major side effect of increased greenhouse gases in the atmosphere is crazy, crazy weather and our inability to predict it. So what does this all mean? Our planet is beginning to heat up because there is more energy in our atmosphere. Where does this energy come from? Well, because there are lots of greenhouse gases in our atmosphere, more than usual. The sunlight, those photons that we talked about a couple weeks ago, are coming into our atmosphere and they're actually staying put for a little bit longer. This increases the overall heat of our planet and the amount of energy bouncing around inside our atmosphere. Well, I'm not going to get too much into the specifics, but basically all this extra energy creates crazy pants weather. I'm talking tornadoes, snowstorms, hurricanes, crazy drought, wildfire, because there's not enough moisture to keep things from burning up in flames. Additionally, a lot of this kind of like these massive dumps of snow or these massive rainstorms or these, large-scale hurricanes are also causing lots of flooding all over the place. So if you ever hear someone say, "But it's cold outside, climate change is a hoax, it can't be real," well, they're just telling you that they don't really understand how climate change works. Basically, all of this extra energy in the atmosphere is causing a bunch of extreme weather. Do you remember the 2019 snow day we had? I remember how excited I was to stay home. Perspective. The important thing to note is that basically climate change is causing a lot of issues in terms of stable weather, stable growing conditions, and overall health and safety of a lot of people on this planet. It's not just about crazy weather, though. Too many greenhouse gases in the atmosphere also cause something called ocean acidification. The ocean actually does a ton of breathing. That is to say, CO2 from the atmosphere is actually constantly being dissolved or is constantly dissolving into the oceans. However, as CO2 levels in the atmosphere increase, so too does the CO2 in the oceans. This is making our oceans more acidic. And is this a problem? Well, it is for coral and other calcium-dependent organisms like mollusks or shellfish. Picture pouring acid on a crab and you might get a sense of the effect of more acidic oceans. Taylor, good job! That looks like such a good fish! I'm so proud. That's so awesome. Oh, wait. No, it's not. This is actually a huge problem, especially because if we think about the entire global population, so much of us actually rely on the ocean for our food source. Second of all, it doesn't matter even if we didn't use the oceans, they still need to be an integral part of this planetary ecosystem. We gotta make sure we're watching out for our oceans. Your first challenge is to actually watch this rad video by the incomparable Billiam Nye. Yes? The science guy. I want you to check out this amazing video. It's called Climate Change 101, and it does a really good job of like a quick punch view of what climate change is and why it's an issue. So I want you to watch this video, take some notes in your journal about what you learned today, based on Bill Nye's video, based on what you've seen in this video as well. What have you learned so far about climate change? So that's it for part 1 of this video series. Today we talked about what climate change is a little bit. We looked at the greenhouse gas effect, we look at greenhouse gases, and we talked a little bit about fossil fuels and where they come from. We also talked a little bit about crazy weather and some of the impacts that this change in the atmosphere and this greenhouse gas effect is actually having on our day-to-day lives. I'll see you in the next video. Was I in frame?
Oh yeah, no, you're perfect in frame.
I'm perfect. You could just stop there. All right, perfect.